In this lesson we're going to look at the properties of covalent substances. Now, covalent substances can be divided into two types. They can be simple molecular or giant covalent. In this lesson we're going to look at simple molecular substances. So here we're talking about where the molecules that are formed are relatively small. Now, these molecules could be the same elements, for example, oxygen, hydrogen, nitrogen, and then the halogens, for example, fluorine, chlorine, bromine, and then iodine. Now notice that these are all elements. They appear on the periodic table, but they all exist as diatomic molecules. So the covalent bonds that hold these atoms together are really very strong bonds. Okay, so these atoms are held together by strong forces. So we should also mention that not only do covalent bonds hold together the same atoms from the same element, but they can also hold together atoms from different elements. Common substances such as water, H2O, carbon dioxide, sulfur dioxide, methane. These are all simple molecular structures that you're very familiar with in your chemistry course. Ethanol, etc. These are all classed as simple molecular covalent substances. Now then, going back to these diatomic molecules, what we can say is that although the covalent bonds are very strong, the forces that interact between the molecules, these are called intermolecular forces, these forces are very weak. Now, as a result of that, covalent substances tend to have very low melting points and boiling points, simply because the forces between the molecules are weak. So they tend to be, as a rule, gases or liquids. Or if they are solids, then, for example, as in the case of iodine, they will be solids with relatively low melting points at room temperature. And thirdly, because these molecules don't have ions, they're covalent, right? So there are no charged particles involved, they don't conduct electricity. So whether a covalent substance is a solid, liquid or gas at room temperature depends on the size of the intermolecular forces that hold the molecules together and on the mass of the molecule itself. Now, the size of the intermolecular force depends upon the size of the molecule. So if we have a look at the group 7 elements, for example, the halogens, in particular we're going to look at fluorine, chlorine, bromine and iodine. Well, you'll see here that the size of the molecule gradually increases as you move down the group. So iodine is a much bigger molecule than fluorine. In addition, the masses of the molecules also increase as you move down the group. So we can expect the forces that interact between the molecules of fluorine to be much weaker than the forces that interact between the molecules of iodine. As a result, fluorine has a lower boiling point. Likewise, chlorine, which is a larger molecule and a heavier molecule, will have a higher boiling point, and then bromine still higher still, and iodine higher even still. So we're not surprised to find that fluorine at room temperature is a gas, chlorine is a gas, but bromine at room temperature is a liquid, since it's a larger molecule, larger intermolecular forces, and a heavier molecule. So bromine finds it a lot harder to get into the gas state. And iodine is a solid at room temperature, and it has a melting point of about 114 degrees Celsius. That's the melting point, with a boiling point of only 184 degrees Celsius.